Good afternoon all. So in the last sessions we have seen many learning methods in neural networks. So if it is feedback loop in neural networks, then what is a training algorithm? So it is back propagation training algorithm or back propagation learning algorithm. So if you see the simple network, a neural network, the signal flow graph will be like this. So the inputs are y0 to ym, y0, which is nothing but, let us assume that y0 as bias, which is positive bias. Anything you can take, but as an example, y0 is equal plus 1, y1 of n, yi of n, yi plus 1 of n, and so on, ym of n. So these are the inputs, and the corresponding weights will be there on the connection links, and the output node or output neuron is jth neuron. The corresponding induced field is Vj of n. So here the corresponding connection links weight will be denoted like the subscript will be the first will be given as output and input, right? So that's why Wj naught. In a similar way, Wj1, J should be the output neuron, that is nothing but jth neuron, then input field. So Wji, which is Wji is the connection link weight from the Wi to jth neuron, sorry, Yi to jth neuron. So in a similar way, Wjm, if you, that is a connection link of the Ym to Vj. So here Ji represents jth neuron to input, that is nothing but Yi to Vj, the connection link weight. Wji represent the J first, I second, but the connection link should be going from Yi to Vj. Okay, then Vj of n, I think this is basic. We have seen these things in the last class also. So Wji, the connection link should not be represent Wij, it should be from output to input. Then Vj of n is the local induced field, and pi of I is one of the activation function. After that activation function will get the overall output, that is Yj of n. Now Yj of n is the jth neuron overall output, that is actual output. Let us assume Dj of n as the desired output. When you subtract the actual output Yj of n from the Dj of n, then you will get the error Ej of n. So that's why that minus 1 will be again. So Dj of n minus Yj of n is equal to Ej of n. That is nothing but error. So this error need to be used to update the connection link weights. The back propagation means, so this need to be connected in a feedback loop. So we will see the derivation of this back propagation learning algorithm. So for the derivation we need few equations. Those equations are error signal at jth neuron. So already we have taken only one neuron, that is jth neuron. The corresponding local induced field of the jth neuron is Vj of n. So Vj of n, what is Vj of n here? Vj of n is nothing but Wji into corresponding input, that is Yi of n. Vj of n is equal to Wji into Yi of n. So then what is Yj of n? Yj of n is equal to activation function pi of Vj of n, pi of local induced field, that is Vj of n. Okay. So here to get that jth neuron error, Ej of n is equal to desired response Dj of n minus actual response Yi of n. That will give the error at jth neuron. So that is the first equation. Let us assume that as first equation. Then the instantaneous error energy for all neurons in output layer. So the output layer error energy E of n is equal to 1 by 2 summation j belongs to C. J belongs to C means that jth neuron belongs to some set C. Ej square of n. So here in the previous class also we were discussed why 1 by 2 and Ej square means you have to differentiate this error energy signal and you need to equal to 0 to minimize the error. So that's why we have taken half and square. When you are differentiating both, you will get only Ej of n. D differentiate on both left and right side, then you will get Ej of n. That error need to be equal to 0. So that's why we have taken that error energy as half summation j belongs to C. Here C is nothing but some set, and in that set j should be there. So jth neuron. If it is kth neuron means kth neuron also belongs to C, like that. So but here we have taken only jth neuron, that's why j belongs to C, that output set neuron. And Ej square of n, that is the error energy signal. Here if n denotes the total number of patterns in the training set, the average squared error energy is E average. Here we are calculating that average energy. Average energy means your actual energy signal is E of n. So if you want to do that, average means there are n number of patterns in the training set. Then 1 to n errors you will get it. E1 of n, E2 of n, and so on. E capital N of n is divided by n, total number. That will be the average. That's what this equation. 1 by n summation n is equal to 1 to n capital N capital E of n, which is nothing but average of all the training set patterns. Error. So next we'll see the cost function. So here generally cost function is represented to minimize the cost function. That's why here cost function is nothing but E average is the cost function, when that is error function only. But generally in the process of that minimization function, cost minimization function, like that we represent. So our objective is to minimize that error, so that error will become the cost function. E average is the cost function. Now the objective is to adjust the free parameters to minimize the error E average. Finally we need to adjust the free parameters. What are the free parameters? That weights, connection link weights need to be adjusted to minimize the error. When you are minimizing the error, what is happening? When you are minimizing the error, you are getting the actual response which is nearer to the desired response. So both actual and desired response will be almost equal by minimizing the error, because desired response minus actual response is a error. When both are equal, your error will be 0 or it is close to 0. So indirectly we are trying to make that error 0, means we are getting the desired response. So for that, what are the parameters we need to adjust? We need to adjust the connection link weights. So that's what we need to do it. So this way the cost function here it is E average. So from the figure 1, from the first figure, the induced local field Vj of n at jth neuron, I have already told you, at jth neuron the corresponding connection link weight will be multiplied with the input yi of n to get the local induced field. So that's why Vj of n is equal to summation I is equal to 0 to m. At the input side, 0 to m it is changing, 0 to m inputs. The corresponding connection link weight will be, anyway jth neuron will be there. That's why Wj I of n. Here I alone it is variable. So I may be 0, I may be 1, I may be 2, I may be j, sorry, I may be I plus 1, and so on m. So wj1, wj2, wj3 are the connection link weights of the different connection links into corresponding input, that may be y0, y1, y2 and so on, yn. Okay, so here we got the local induced field. Then hence the functional signal will become, that is overall actual output will become yj of n is equal to activation function pi of vj of n. So I think I'll go to that. If you see vj of n is equal to corresponding connection link weights will be multiplied with the corresponding input, that is yi of n, wji into yi of n. Yj of n is equal to pi of vj of n. That's what here everything. Okay, functional signal is nothing but yj of n is equal to pi of vj of n. Next, if we come to the back propagation, in back propagation the change in synaptic weight, that is wji of n, is proportional to the partial derivative of cost function with respect to the weight. Your error you are getting in terms of weight, the partial derivative of that cost function will give the corresponding change in weight, synaptic change in weight. So for that, what that means, what it is, your error is nothing but e. So partial derivative of that error with respect to the weight means dou e by dou wji of n, dou e by dou wji of n. But your error is not directly differentiable, partial derivatable with respect to the with respect to the weight, that is wji of n. But according to the chain rule in calculus, we can rewrite the same dou e by dou wj of n like equation 6. So here dou e by dou wji of n is equal to your error. If you see the error equation, that error equation is a function of ej of n. Then you differentiate that error equation with respect to the ej of n, that is nothing but dou e of n by dou ej of n. Then again in the denominator you got ej of n, in the numerator you need to differentiate that ej of n. That's why dou ej of n by dou yi of n, dou yj of n. So here ej of n is function of yj of n. That's why we are differentiating that ej of n with respect to the yj of n. Again in the denominator you got yj of n. So you need to differentiate yj of n in the numerator. So dou yj of n is divided by dou vj of n. That vj of n is function, yj of n is function of the vj of n. That's why dou vj of n by dou yj of n is divided by dou vj of n. Again that vj of n is differentiable with respect to the weights wji. So dou vj of n is divided by dou wji of n. Now if you see, everything will be get cancelled. At last dou e of n by dou wji of n. But you can get the individual differentiations by going through that corresponding equations. So I think if you see that equations, you'll come to know. Differentiating the equation 2 on both sides. See, here we need to get the first dou e of n by dou wji of n. To get that one, first what we are doing, dou e of n is divided by dou ej of n. See that equation 2. Error equation. E of n is equal 1 by 2 summation j belongs to c ej square of n. So here we can differentiate with respect to the ej of n. On the left side and right side, if we differentiate with respect to the ej of n, dou ej of n is divided by dou small ej of n. On the right side, if we differentiate, what do you get? Ej of n, you will get it. Half into 2 into ej of n, you will get it. So differentiating the capital E of n with respect to the small ej of n, you will get it as small ej of n. In the second term, what is ej of n? Second term is dou ej of n is divided by dou yj of n. See that ej of n equation, whether it is differentiable with respect to the yj of n. What is ej of n? First equation is ej of n. So both sides, if we differentiate with respect to the yj of n, dou small ej of n, first equation if you see, dou small ej of n is divided by dou yj of n is equal to, first one is constant dj of n, second one is with respect to the y, means you will get 1, that is minus 1. Dou ej of n is divided by dou yj of n, from the first equation you will get, it is equal to the minus 1. So next equation, third term is dou yj of n is divided by dou vj of n. Let's go to the yj of n equation. Third term is dou yj of n is divided by dou vj of n. Where is yj of n? Yj of n is function of pi of vj of n, right? So we are differentiating with respect to the vj of n, means on both sides if we differentiate, dou yj of n is divided by dou vj of n is equal to, it is function, whatever it function, that can be derivative, but here we can directly represent it as pi dash of vj of n, that is differentiated. Okay, derivative pi dash of vj of n on the right side. On the left side you will get dou vj of n by dou yj of n is divided by dou vj of n. What is the fourth term? Dou vj of n is divided by dou wji of n. So what is the vj of n equation? That we need to see. Dou vj of n is divided by dou wji of n, means vj of n should have the function of wji. See that vj of n equation, fourth equation. In the fourth equation, it is a function of wji. So when you differentiate derivative on both sides, dou vj of n is divided by dou wji of n is equal to, on the right side you will get only yi of n, because when it is differentiating with respect to the wi of n, only one wi of n term is there, that is equal to 1. So remaining constant is wi of n. On the right side you will get wi of n. So when you rewrite the sixth equation, by after differentiating the individual equations, that is by differentiating the equation 2 on both sides, you will get dou e of n by dou ej of n is equal to small ej of n. You will get it as we have already seen. Just to go through properly, going back to that equations like what we have seen. Differentiating the equation 1 on both sides, that is dou ej of n by dou yj of n, you will get it as minus 1. Differentiating the equation 5 on both sides, you will get dou yj of n by dou vj of n is equal to pi dash of vj of n, because pi is function, whatever it function, that can be differentiated, that's why pi dash of vj of n, you will get it. Differentiating the equation 4 on both sides, you will get dou vj of n by dou wji of n, which is equal to yi of n, because if you see that equation, only one wi term is there, so that can be differentiated and it is equal to 1, and the corresponding connected constant is wi of n. So substitute all these equations which we are derived from this 7, 8, 9 and 10 in the sixth equation. Sixth equation is this one. In this equation, dou e of n by dou wji of n. 4 terms are there here on the right side, and here we derived that 4 terms after derivating or differentiating 7, 8, 9 and 10. By substituting these 7 to 10 equations in the sixth equation, you will get minus ej of n. Just I am substituting all these terms. In the seventh equation, ej of n, I got it. In the eighth equation, minus 1, I got it. Second term. Let us take in the third, in the ninth equation, pi dash vj of n, I got it. In the 10th equation, yi of n, I got it. All these 4 will be multiplied and kept it on the right side of that dou e of n by dou wj of n in the 11th equation. that is equal to minus Ej of n pi dash Vj of n into Wi of n, that is equal to dou E of n by dou Wji of n. So these are the required derivative for this back propagation training algorithm. So here all terms are there, just you need to differentiate. Even while you are doing the updating the weight needs to be updated based on that equation. So how that weights will be updated? Here according to the delta rule, so delta Wji of n is nothing but learning rate, whether it is minus learning rate parameter into dou E of n by dou Wj of n. So already we have derived that dou E of n by dou Wj of n. So that is nothing but 11th equation, dou E of n by dou Wj of n. So the change in weight we need to calculate by multiplying with the learning rate parameter. So that is nothing but neta into dou E of n by dou Wj of n. If it is minus or plus, that need to be whether it is added or subtracted based on that. So by substituting that 11th equation, dou E of n by dou Wj of n, 11th equation, in this 12th equation, what do you get by substituting that 11th equation in the 12th equation? Del Wj of n is equal to neta into minus, and in the 11th equation you have minus. In the 12th equation also you have minus. Then that will be multiplied. You will get only neta into simply that Ej of n into pi dash Vj of n. I am denoting it as del j of n, and into yi of n. 13th equation you got it. So here del j of n is equal to Ej of n into pi dash Vj of n. To find out this del j of n, again you can do that partial derivative. Del j of n is nothing but dou E of n is divided by dou Vj of n. Dou E of n is divided by dou Vj of n, where that minus actually, if it is multiplied, you will not get that minus. If you don't take that del as negative, you will get minus here. So actually minus into minus neta in the 12th equation, minus neta into dou E by dou Wj is there, right? Dou E by Wj, in the 11th equation we have minus and minus will be multiplied, you will get plus only. So here del j of n will get plus only, and this, otherwise if you do not take that minus, here you will get minus. So dou E of n by dou Vj of n is equal, again here also to get that, already we have seen this chain rule in calculus. In the 11th equation we have seen, right? Yeah, not 11th equation, the 6th equation. So from the 6th equation you can take that dou E of n by dou Vj of dou Ej of n, dou Ej of n by dou Vj of n, dou Yj of n by dou Vj of n. So that term we can calculate from this partial derivative. So like this we can get this local gradient del j of n. So here del j of n is called the local gradient. That local gradient is called because remaining things, why this del j of n is called the local gradient, and why not that yi of n is also included in this local gradient, means here learning rate parameter is we need to provide, and yi of n is the input. The remaining terms are we need to get it from the network only. That's why yi of n is input, learning rate parameter will decide, del j of n we need to calculate from this equation to get that change in weight. So here two cases are there. In the case 1, if neuron j is an output layer, already we have taken that jth neuron as output layer, right? It is supplied with a desired response of its own. Desired response will get directly because desired response is connected directly to the jth neuron. by using that equation 1 is nothing but error equation. Error is nothing but desired minus actual, dj of n minus yj of n, to compute the error signal. And equation 14, so equation 14 is nothing but local gradient. Here also, by differentiating that, you will get that local gradient. The local gradient can be calculated, because in the first case you are getting your desired response directly, it is connected to the jth neuron. In the second case, that is not a problem. If this jth neuron is directly connected to the desired response, that's why it is single layer network. That's not a problem. With these equations we can directly get it. But if jth neuron is the hidden layer, it means if it is hidden layer means after j we have another neuron, that is kth neuron. After k we have another neuron, L neuron, likewise. So jth neuron, if one of the hidden layer, then it is not supplied with the desired response of its own, because after jth neuron you have kth neuron also or other neurons. So which is last neuron, that will be connected with the desired response. So a new approach is adopted to calculate that local gradient. That means for that multiple layers, like what we have done so far, in a similar way we need to do it for the multiple layers also. For example, you need to do it, for example, jth neuron is there, then after jth neuron kth neuron is there. After kth neuron you are getting the desired response, then kth neuron and desired response, only kth neuron and desired response. From that you can do it like a single layer network like this. Then the corresponding error will adjust only kth neuron connection link weights. After that again we need to come to the last but one layer, that is jth neuron. Then from the jth neuron to input, likewise we need to do it. So this is all about the back propagation training algorithm. Thank you all.